I want to talk about one thing. Yeah, the video thing. Yeah, yeah. Because recently I noticed some important thing in Canvas. You know, our video is blocked by Canvas. So the video file, you can see when I click it, error occurred. Yeah. Based on the message, it is blocked. Okay, the Canvas embedded the video. All right, and I added this clickable link. Yeah, this link is clickable. Okay, if you click it, but the clickable link is also blocked. If you click, also block it. Okay, so these two ways block it. Yeah. Then I add a third way. Third way. This is non-clickable link, because this you can copy paste. This non-clickable link, you just highlight it, then you bring up your web browser somewhere, copy paste, enter. Why so slow? Enter.
Maybe you want to try the Chrome page?
Yeah, I can try Chrome. Yeah, but I think it should be okay. Yeah, my Chrome. Yeah, I can try. I tried that. Yeah, but that browser is, because this place, it is blocked. Yeah. All right, let me get my Chrome. This is my Chrome. Yeah.
Bridge case efficiency of binary
Yeah.
search.
So this is one way. All right.
Remember,
Yeah.
at the end of
But here, several ways you can choose from here. Another way, you can download it. Yeah. Before you could download to a local file, because local file, it is not blocked. Okay? So here, every time before you just need to do a little more things. So here, let me try. All right, so here, I just show you, we download somewhere. Okay? Yeah. So here, let me just, put somewhere. Okay? Yeah. All right, so I put some place there. Now it's a local file. So it's not in the Canvas environment. So local file, here, yeah, whatever, here, you click it, yeah, then it's not blocked, okay? In that, this video you can watch directly.
bridge case efficiency
Right.
of binary.
Yeah. So here you can see several ways, but you need to do a little more things. Yeah.
I think you can fix it by going to settings.
Oh, you can fix by yourself?
I
Yeah.
think, like if you
Oh,
go to settings, privacy, say settings underneath JavaScript.
JavaScript. Okay. Yeah.
I can
Okay.
show you the
Oh, yeah. Yeah. I did that before. Yeah. Yeah. Oh, no. I didn't try this one. The message says that, but the thing is, we can view before, right? We can view before, but suddenly we cannot see it. We cannot see it. Although we can try, because I enable JavaScript. I always test JavaScript in Chrome. I never block JavaScript.
I don't know why that.
Yeah. So the thing is, that error message, I figure just, block the video, block the embedded, and even link also block it. Yeah. Yeah. All right. Yeah. So you can try, but here the solution I thought. So these two solutions. Yeah. Third one. There is a third one. Some students just subscribe my channel. Okay. Subscribe my channel. So when you see I post a video file, you just go to my channel to view. Yeah. So these three ways you can view the video. Not very convenient, yeah, but you need to do a little more things. Yeah. So I plan to write instructions for these three different ways to view the video. So that I post my instructions. Yeah. Yeah, so that's the first thing. Yeah, because when I look at the views in my YouTube channel, it dropped significantly. Okay, after it blocked it, because many students they do not bother to view it. So when they see block it, so then they just leave. Yeah. So here you can see if I go to my YouTube channel, you can see the number of views very small. Yeah, so this is my YouTube channel. Yeah, so here I go to the video I posted. Yeah, see the number relatively small. Yeah. You see these numbers less than 10. You see, I posted about 1 week. But still less than 10 number of views. You can see. Yeah. All right. Yeah. So that's the first thing I want to explain. Yeah. Because we will near the final quickly. Yeah. So you need to study the videos. Yeah. So that's one thing. Yeah. All right, so there, let's continue our lecture. Yeah, I already recorded. Yeah, so here I'll just bring up the lecture what we left last time. Part A, the second half of part A. 8.3. All right, yeah. Primary index. So now, I want to explain two most important types of indexes, index files. Yeah. Two commonly used index files. The first one is this called primary index. Yeah. So let's study the basic structure of this index. Structure, yeah. An ordered file, yeah. Actually, I already explained a little bit last time the structure. Yeah. So here, let's learn some more. An ordered file whose records are of fixed length with two fields, key field and a pointer. Fixed length. Each entry, yeah, we know, entry we store the fixed the entries in the index file as a sequence. But each entry, the size of an entry is fixed. Yeah. So that's the fixed length with two fields. Yeah. All right. Primary key of a primary index, then the concept here. So this could be confusing. We learn the primary key of a table concept, yeah. But here it's a primary key of a primary index. So this concept here is different from primary key of a table. Yeah. Be aware of this. Yeah. So let me write here. So it's different from the primary key of a table. So that's our old concept. Okay? Yeah. This time the primary key of a primary index. Okay? Yeah. Yeah. If it's not primary index, yeah, later we will learn the second type of indexes. Yeah. It's not a primary index, so then you don't have a primary key, right? Yeah. So here, yeah. All right. The first field of the same data type as the ordering key field of the data file. Let me explain this sentence. Yeah. So what's the primary key of a primary index? All right. So let me draw a simple diagram here. Yeah. One original table, one primary index. Okay. One primary index. All right. Suppose this is an original table. Okay. All right. So original table. There are many fields. So here I just draw a few fields. Okay. Yeah. Suppose we select one key field, one of the key fields in this original table. Now, you may have multiple key fields, but here we select one of the key fields. Suppose this key field we want to select. Okay, yeah, a key field. All right. Yeah. That primary index. So then I draw primary index here. Remember 2 columns. Yeah. Like that. Okay, all right. The first one, primary key of the primary index. Okay, yeah, the first column. The second pointer. All right. So the primary key, so that's the entries, right? Yeah. Entries. Yeah. So here we say the first field is the same data type as the ordering key field. Ordering key field. The key field, yeah, we select key field. And ordering. So the field values of the key field is ordered. Yeah. Ordered. Yeah. Ordered. Yeah. So yeah, probably here we should say ordered. Yeah. Because ordering, so you can order it. You can order it. Right? The ordering field. But here, it must be ordered. Yeah. So here the meaning actually should be, the key field must be ordered. So it must be ordered, ascending order. Okay. Yeah. So this key field actually, oh sorry, why I cannot erase. Yeah. Yeah. The key field must be ordered. Yeah. Okay. Ordered, ascending order. Yeah. So this probably is important. Oh, sorry, ordered, ascending order, increasing order. Okay, yeah, ascending. Yeah. The reason. Yeah. So here, important. This property. Yeah. The reason is later, when we learn more properties of the primary key structure, you can see. Yeah. So if it's not ordered, we cannot use the primary key. We need to use a different type of, we cannot use the primary index. We need to use a different type of indices. Different type of indices. Yeah. The reason, if it's ordered, yeah, so here, important. So here I emphasize ordered property of the key field. So here, I emphasize ordered property of the key field. Okay? Yeah. Because if it's ordered, we can make a good prediction. We can make good prediction. Okay? What do you mean? I explain this. Make good prediction. What's that? Because if it's not ordered, you cannot make good prediction. The good prediction is when you use ordered property, okay, ordered property, so you know it's ordered, that you do not have to use all the ordered key values here. You can jump. You can jump. Okay? So you only need to store part of the ordered keys. So that's the reason. Okay? Yeah. So with ordered key values, in your primary index, you can skip. You don't just store all the possible entries. You store part of it. Okay? You can skip many records in your primary index. Because you can make good, the skipped part, you can use prediction to get it. Prediction. Okay? Yeah. All right. Yeah. So I will explain detail. So here I give you the main reason. So why we can use primary index in this situation based on the ordered data. All right. Yeah. So let's look at a few more. Yeah. The second field is a pointer to the disk block that contains the record to be searched for. Okay, all right. So here we need to get to the disk block. Last time at the end of the class, I drew that disk block structure. Yeah. Here I just picked the main part. I need to explain the. Yeah. All right. Yeah. The number of index entries. There is one index entry. So here, let me see. In the primary index file for each block of the data structure. Block in the data file. Let me explain. All right. So here, from this sentence, because after this sentence, I can show you the detail of the structure. There is one index entry for each block. So here you can see the one-to-one correspondence is between one index entry and one disk block in the data file. Disk block in the data file. Okay? All right. Last time when I drew the block structure, I should show you, we use disk block to store both original data file and our index entry file, right? Yeah. Store in disk block. Here the pointer points to the disk block of the original data file. Okay? So one entry for one block. So that relationship, one entry corresponds to one disk block. Okay? We know one disk block can store multiple records, right? One disk block, usually, in general, we can store many records. Yeah. So it is not one entry corresponds to one record. So it's a one entry corresponds to multiple records in a disk block. That idea, okay? That idea. One too many, okay? That idea, yeah. The reason we can do that, one disk entry can control multiple disk block, not multiple disk block, one disk block, multiple records in the disk block. So one entry controls multiple records in the original file within one disk block. That structure, okay? All right. Yeah. So let me draw a little bit. Okay, all right. Suppose this is I just draw one entry. Okay, so this is one entry in the primary index. One entry. Okay, pointer. Yeah. All right. Index. All right. That disk block, okay, all right. So here, I draw disk block in this way. This long bar represents one disk block, okay? The size, block size. All right. Then we use this disk block to store the records in the original file. Or table, original table. Yeah, all right. One record. Yeah. So suppose this is record 1. Okay. Yeah. Yeah. R1, record 1. Consecutive record R2, and so on. Okay. R2. The last record. Okay. Rn. Okay, and some space, usually some space wasted, okay, because not enough to hold one complete record. So we have to leave there. So wasted. Yeah. All right. Then this entry, there is a pointer, right? Point to the location of this disk block. Yeah. So here, based on, so this one entry point to the in the primary is for the disk block, each block, but this pointer needs to point the location of the disk. So the question, what is the location of this disk block? Location of the disk block. The location of the disk block is the location of the first record. The first record, its location is the same as the location of the whole disk block. Okay, so that's how we call this first record. Anchor, yeah. Anchor record. Yeah. Yeah. So we point this one. Okay, yeah. Anchor. Yeah. Anchor record. The first one in this disk block. So we only need to point to the location of the first record in this disk block. Because when we load the data, we load the whole block, right? Yeah? Every time we load the whole block, when we need to load the data into the main memory, load the whole block. Okay? Load the whole block. Yeah. So the reason is simple. The reason that I explained last time why you load the whole block The reason is, we know each trip, each visit to the hard drive very slow, right? Each visit to the hard drive, hard disk, very slow. So every trip, we want to carry more records. You don't want to you carry only one, not efficient. Yeah. Remember, there is in computer science, there is a very important principle called the principle of locality. Principle of locality in computer science. Okay, so it's called the principle of locality. What's that? Two meanings. Principle of locality. There are two meanings about it. Spatial meaning and time meaning. Yeah. Regarding the space, there is a principle of locality meaning. Okay, space-wise and time-wise. Yeah. Two meanings. Space-wise, when you access the data at some location, it is very likely next time you access the data nearby, near the state, local, okay, locality. Yeah? Yeah, because think about in an array, you store the elements in array occupying consecutive locations, right? When you access data in an array, you access data, following this locality, okay, principle of locality. So that's the, space-wise principle of locality. Then time-wise, also, there is a principle of locality. So if you access the data recently, it's very likely you access the data, you just accessed recently. Okay? Also, locality. Also locality. All right? Yeah. Time-wise, principle of locality. Here we use the spatial meaning of locality. Spatial. Now, because if you access R1, then the next time it's very likely you access R2. And then very likely next time R3 and so on. Then the first time when you access R1, you load the whole block into the main memory. Then when you access R2, you do not need to pay another visit to the hard drive, right? Because it's already in the main memory, right? R3 already in main memory. You do not need to go another visit. So for that reason, so we want to, load the data block by block. And our block cannot be too large because, some of you may feel, since each trip, can we carry more records, right? Yeah. So here, 100, for example, 100, how about you carry 200, 300? Yeah. The bandwidth limitation, right? Because how do you carry the disk block? The hardware, there is a bandwidth, your data bus. Remember, how do you send data? Okay? Through the data bus. Data bus has a bandwidth, right? The bandwidth just this wide. The width is fixed. If your buffer is too large, you need to break your buffer into several pieces. Then you say each time you can only set one piece through the data bus. Then it's just like you load multiple blocks, right? So your block size is limited by the data bus, the bandwidth of the data bus. So it cannot be too large. Yeah, just the right. Not too small, not too large, just the right. The disk block size. All right, so with this understanding, so then you can understand the primary index a little better. Okay? Yeah. So that structure. Yeah. So one entry corresponds to one disk block. That disk block contains multiple records in the original table file. Yeah. All right. Yeah. Next, anchor record in primary index. Yeah. So let's study this anchor record. Yeah. All right. Each index entry has the value of the primary key field for the first record in the block. That location of that anchor block, the same location we use for the disk block. Okay? So, you know, binary string, a binary string, location. Yeah. Each disk block usually contains multiple records. Yeah. So remember 4K, so last time most companies use the block size 4K. Yeah. So in that 4K, so you can hold, you know, multiple records. Yeah. All right. It is called an anchor record. Yeah. All right. A primary index only stores the field values for the block anchors. Yeah. Okay? All right. So here, based on this understanding, let me draw another diagram. Yeah. So this time, so we can, you know, see the picture a little better. Yeah. The diagram. Yeah. So, yeah, because here I use the, you know, horizontal way to draw this diagram. Yeah. This time I want to draw multiple blocks, yeah. Not just one block, multiple disk blocks. Yeah. All right. Yeah. Block 1, yeah, so suppose this is block 1. Yeah. This long, okay? So this is disk block 1. Block 2. Block 2. And block 3, okay? Yeah, 3 should be enough, yeah, to show you the idea. Yeah, so we know, you know, many blocks. In block 1, so we have, you know, many records, R1, R2, and so on, okay? All right. So here, let me, you know, just R10, how about that? 10 records in one disk block. Yeah. So then the next one, R11, R11, R12. Last one, R20. Okay? Yeah. Yeah. So another one, R21, R30. Okay? Yeah. So this is the, you know, natural storage for the original file on the hard drive. Hard drive in this way. All right? Then our primary index, yeah, based on this structure. Now, our primary index. Yeah. Yeah. All right, so this is the, you know, original table. All right. This is the primary index. Okay, all right. Yeah. Entries. 1, 2, 3, 4. Okay. Entry. Yeah, let me use E1, E2, E3, and so on. Okay. A sequence of entries. E1, we store the value, R1 value. Okay. Yeah, R1 value. Yeah. So let me use R1V. How about that? Okay. And pointer 1. Yeah. The second entry. Yeah. Anchor, remember, we use the anchor record. That is anchor record. This is anchor record. Okay? This is the anchor record. The first one in each block. So the next one, R11V. See, we skip, you know, R2 through R10. Yeah, because we do not need to store R2 through R10 in our primary index entries. We can skip. We can skip many of them. So PTR2, R21V value, PTR3, and so on. in this way, you can see the size of our primary index could be very small. The smaller the size, when we do binary search, it's faster, right? Think about it. Because we need to use this primary index, we do the binary search. When we apply the binary search, yeah, it's much shorter. You know, we take log of base 2, that number smaller. Okay? Number much smaller. Okay? Yeah. And if you ask me why we can scale, because we can make prediction easily. Yeah. The next slide I will talk about. The algorithm, we can make this prediction very well. Prediction on the missing part. Yeah. Why? Because the prediction always between two adjacent anchor records, right? Yeah. The missing part always between two adjacent anchor records. How about that? And we store the values of those two adjacent anchor record, right? The values. Yeah. We store that. And the values between these two adjacent values of the anchor records, we can predict easily. See? Yeah. That's the reason. So this type of index file can save a lot of space, and it can make the search much faster. That's the idea, main idea. Okay, all right. The total number of entries in a primary index is the same as the number of disk blocks in the ordered data file. Yeah. Same number, yeah, disk block. But we know the entry size is much smaller than the record size, right? Yeah. So each disk block can hold many more entries in the primary index. Yeah, the size is small. Yeah. Yeah. So the primary index. Okay, all right, yeah. So here you can see. Yeah. So this type of index, you can expect its performance is very fast. Search performance, very fast. All right. So, yeah, this number is usually smaller than the number of records in the original file. Yeah? Because we skip so many records in the original file. Okay. Yeah. In this example, 1/10. The size is 1/10. Yeah. And many times, one disk block can hold more than 10 records. More than 10 records. Dozens of records. Yeah. Yeah. So there, you can see the number already reduced. Let's say, 1/20th, 1/30th in that level. Approximately in that level, yeah, 1/20th, 1/30th, from the number in that level, but the size of one entry is another 1/10th something of the size of the original record. Another 1/10th. You think about that. So 100th, you can see the size of index file is about 100th of the size of the original data file. You can see that compression ratio. Pretty significant. Okay, pretty significant. Yeah. All right. Yeah. Performance of primary. Here, let me show you how do we apply the binary search to find the record with the given search key. Yeah. Given search key. Yeah. We want to find location, and we want to load that record into the main memory. Yeah. So here, let me show you, step by step. All right. Size of a primary index file. There are fewer index entries than there are records in data file. Yeah. We skip so many. Okay. Yeah. Each index entry is typically smaller in size than the data record because it has only 2 fields. Yeah. Only. Right. Yeah. All right. More index entries than data records can fit in one block. Yeah. So all these factors contribute. You know, the size of a primary index file is much smaller than the size of original data file table. Okay, all right. Then we apply binary search on the primary index. Okay, all right. The performance, we know, log base 2, right? Now binary search. Yeah. Log base 2 of the number of primary index entries, the entries in our primary index file. Yeah. Here we take the seeding function. Yeah. Seeding function log base 2 parenthesis m plus 1. Yeah, sorry. This m I like to, you know, it refers to number of entries of the primary index. Okay, yeah. All right, yeah. Yeah, so here you can, yeah, much smaller number. Yeah. Yeah. When this, because this number corresponds to the number of visits to the hard drive. Yeah, so this number corresponds to number of visits to the hard disk for the record to be searched. For, right? Yeah. Same. Yeah. So this number, if we can make it as small as possible, then we can reduce the number of visits to the hard disk. All right. Yeah, that's a good thing. Yeah. All right. Then I want to make some comments. So far, it looks like, you know, so good. This primary index, you know, performance, so good. Yeah. But we need to consider the drawback. So because this primary index also has a significant drawback, we need to consider. This drawback limit the, you know, put some strong restriction on the usage of primary index, reduce the usage of the primary index. Okay, yeah. So it's, you know, biggest the drawback. Yeah. What's that? The drawback. Because it requires that the index field, the index, the values, the values of the index field must be ordered in the original data file. That's a big restriction, right? The values of the index field must be ordered, ascending order, in the original data file. That's a big restriction. Big restriction. Because in the real world situations, the percentage to get this ordered indexing field, that percentage usually not very high. Not very high, that percentage. Okay? That means this primary index is not that, the usage of this primary index is also not very high. Okay? Also not very high. Yeah? Not so useful. Only when you have this property, okay, this ordered, value, index ordered. Only when you have this property, then you can use this primary index to get a very fast search performance. All right. Then another thing. So here, when we talk about this primary index, another thing I want to mention. So because I searched some online articles regarding the primary index topic, there many online articles, describe the primary index differently from our textbook. But I feel our textbook is, is better. Yeah. So from the logic point of view, our textbook way is better, because in many online articles, sorry, because you may have a chance, when you read articles regarding this topic, so sometimes you may get surprised. Because it's different from what we learn from our textbook. The main difference is this. In the articles, they apply the primary index only on primary key of the table. Okay? But actually not necessary. We know not necessary. Okay? So those articles apply the primary index only on the primary key. So if it's not primary key, then you cannot apply primary index based on those articles. Okay? Yeah. But for our textbook, we can apply primary index on any ordered index field. Not necessarily primary key. Okay, any ordered key field. Yeah. Only on the primary key field. Primary key. That's the main difference. Then even more restrictive, right? Even more restrictive. Although many business probably you order, but too restrictive. Okay, too restrictive. Yeah. Because think about when we use social security numbers as the primary key. Very common, right? Social security number as the primary. How people store the original data with social security number in ascending order, right? It's rare. It's rare in ascending order. Social security number in ascending order. It's rare, okay? Yeah. So you can, then you even reduce the usage of primary key even more, okay? Even more. But it's not necessary, yeah? Because think about the purpose using primary
index. The purpose, we can apply binary search to make good prediction, right? That's the purpose. Binary search, make good prediction. If you have an ordered key field, then you can apply binary search and skipping large portion of the original records with good prediction. You can do it. Why you need to restrict yourselves on the only on the ordered primary key? So so that's something. So I feel those authors, so they do not have good understanding. They just, why they say primary key? Because of this name. Because our primary index, this name contains a primary. So there, they just assume this type of index can only be applied on primary key. That's wrong. This primary, so it's a, I think it's the origin, the meaning here, the primary index is the main type of the index. Although it says main type, but based on the percentage of the usage, my understanding, because the percentage is not that high. The percentage using this, if you require, the ordered index field, in general, the percentage is not very high. If the percentage is not high, how can you call it the primary, right? Yeah. How can you call it primary? Yeah. So that's something may not be quite right. Yeah. All right. So then, I want to describe the second type. Second type, more useful. More useful because it does not require ordered values for the indexing field. No. We don't need. Assume your original table must be ordered based on one particular indexing field. They're more useful, right? More useful. Any table. Any table, any field, we can create an index file. We can apply binary search. But the result, when you do that, not as fast. We need to sacrifice a little bit in performance. Yeah, definitely, we cannot make good prediction. The thing is, without that requirement, we cannot make any prediction this time. If the data is not ordered based on any particular field, no prediction we can make. If no prediction, then we need to store all the record information in our index file. All the record. Yeah. You cannot miss anyone. If you just skip one, you don't know where to find it. You don't know where to find that particular record. All right? So, but that one, the percentage is much higher. Because we can always do that. We can always do that. No restriction. Right? No restriction. Yeah. All right. Yeah. So, maybe use 10-something minutes to describe the second type. Yeah. More useful type, I think. All right. Yeah. Binary search based. Yeah. Because we can still apply binary search. Okay. Based. Yeah. But here, order the files. Yeah. I already explained. I can do a little faster. Table can be sorted. That's a requirement. So here, table can be sorted. Actually, we are preparing for our next type of index. Because we don't want to sort original table, but we can sort our index file, right? Yeah, index auxiliary file. Well, we can sort. Original table, we don't want to touch it. Okay? We don't want to change it. So we keep the original data, business data. Whenever we want to change the original business data. But in our auxiliary index files, then we can do the change we like. So table can be sorted on some index field. So now we prepare for the second type of indexes. All right. An index file is created and index entries are sorted in order to apply the value. Yeah, so this time, index entries, this time you can see one table record, we need to use one index entry. So here the relationship is one-to-one correspondence is one entry corresponds to one record in original table. It's different from one entry corresponds to one disk block, right? Yeah, the structure of the primary index. One entry corresponds to one disk block. So we skip large number of records. Here we cannot skip any. Okay, one-to-one correspondence. No record can be skipped. Yeah. So later we call it dense index. Dense, one-to-one, no missing, dense. The previous one we call a sparse index. Sparse. We only need to store small portion of the information from the original table. Sparse index. Okay. All right. If both data file and index file are ordered, why? Yeah. So here, here just the thinking. Yeah. So here the thinking. Yeah. Both data file and index file ordered because the size different, right? Yeah. Yeah. If the data file order, we can use the primary index. So we do not use this. Yeah. So yeah. Here. But here, just we want to think about, because here you do not skip. So here the question should be, here because you never skip any records in your index. How can you make your search much faster? Yeah. Because the data size is still quite different. Yeah. Usually, the original data has more fields, contains larger amount of data. The data size is larger. Yeah. Index file only two fields, key and a pointer, so the size is much smaller. Okay, all right. So larger file uses more disk blocks. So, yeah. You use fewer disk blocks, so your disk access is much faster. Yeah, all right. Smaller file results in fewer disk accesses, so they're faster. Yeah, but here, the topic here, because we target, we target to that dense index. Yeah, dense index. Dense index, we do not skip any record. Yeah. But we can still do it very fast. Yeah. But not as fast as the sparse index, the primary index. Not as fast as that. Yeah. But still, that's the best we can do, because we cannot apply primary index. So this is the best we can do if the original data file is not ordered. Yeah. All right. Yeah. Oh, sorry. Yeah, we finished this topic. Yeah. Anyway, we finished it. Yeah. Because here, just give you the idea. Yeah. The concept, dense, sparse. Yeah. So in part B, the second half, I talk about that concept. Okay, sparse index, the dense index. Yeah, that concept. Yeah, but here we have some minutes. I want to talk about a few slides in part B. Okay, yeah. We don't want to waste that. Okay, yeah. Let's say 7 minutes. Yeah, I use 7 minutes. So probably at least we can go one slide, okay, 1 or 2 slides. Yeah, but very likely one slide. So let me get out of part A first. Then we go to part B. So now, part B we have one half of it. We talk about index. Then this index topic is, we have enough background knowledge. All right, so part B here, B.1 exists function, So there is this function is simple but very useful. So we can use this function. We can do, many complex queries. Yeah. Here. All right. So let me talk about. Yeah. So I hope I give you, at least one or two slides. All right. All right. Exists function. From the name, you can, if the search result, remember, outer query, inner query, when we apply this function, inside this function, we have an inner query, right? Yeah. So here you can see, if the inner query, the result exists, that means not empty, right? If it's not empty, it means exists. If the inner query result is empty, nothing, then the exist function return false. So true and false. Yeah. So that's simple. Yeah. All right. Check whether the result of a correlated nested query and the inner part, okay, yeah, is empty, contains no tuples or not. Yeah. So that's simple. The logic is very simple, yeah. Yeah. But very useful. Very useful. Okay, we use this function. True if the nested query result contains at least one tuple. Not empty, it's true. Okay, all right. False if the nested query result contains no tuple. Yeah. No. Okay. Empty, yeah. It's false. Yeah. All right. Then you have not operator, right? Negation. So you can change. So not exists. You can use not exists. You put a not in front of exists function, then you switch true and false. Yeah? Because sometimes you may like the other way. Yeah. Negation way. The other negation way may be easier. Yeah. Yeah. So not exists function. Yeah. True, empty. Yeah, because sometimes you like to select those, the condition. Inner query, you want to make that condition. Inner query, you want it to be empty. Yeah. So not exists. Yeah. Very convenient. Yeah. All right. False, yeah, not empty. Yeah. These two versions. Yeah. Yeah. All right. Yeah. Very straightforward to understand. Yeah. But you can imagine. Yeah. So when you work on something, the problem relatively hard, but if you use these simple functions, yeah, then you can make it, quite easy. Yeah. All right. Exists, not exists, typically used in conjunction with the correlated nested queries. Yeah. Yeah. So then I show you. Yeah. So I have a few minutes. Let me show you one example. Yeah. Simple example. Yeah. All right. Example using exists function. Compare. Yeah. It's two versions. One we do not use exists function. Another version we use exists function. Yeah. One version, select first name, last name from employee, dependent D, then join condition, the first condition, join condition, second selection condition, then third, same sex. So here you can see, same sex. So the employee and the dependent, they have the same sex. So we want to select those employees, satisfy this condition. Okay? Yeah. Yeah. Oh, and another condition. Yeah. So here, two selection conditions. One is the first name of the employee is the same as the name of the dependent. Yeah. The second is, same sex. It's two selection conditions. Here we do not use exists condition, right? Yeah. Yeah. Although this question very easy, but we want to practice. Yeah. So in this situation, so we use the thinking of this exists function thinking. Okay? Yeah. Although not necessary, yeah, but this, because we want to practice, this exist function give us another powerful way to write relatively complex nested, correlated nested queries. So we want to practice. Yeah. All right. Our second version, we do this way. All right. See, outer query, simple employee, right? Outer query, simple employee. Yeah. So the inner query, then we put all the conditions in the inner query. Okay? Yeah. Outer query employee, and we fix the SSN. Yeah. When we go to inner query, then we compare. Yeah. All the ESN the same as the employee's SSN, but then two selection conditions and the results exists. Look at that. And we want to select those employees. The inner query result not empty. Very straightforward. See? Here you can see, here, when we use this way, we do not join two tables, right? So here, outer query, inner query, we do not join table directly. But we use the correlated structure of the queries. Correlated. So, yeah, different ways. Yeah. Different ways. Yeah. But this kind of thinking, this kind of logic, okay, yeah, is very useful, yeah, when you work on, some relatively complex, nested, correlated queries. Yeah. All right. Yeah. So we run out of time. So let me stop right here. Yeah. So we can quickly complete this part next time. Yeah. 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 Because pretty straightforward. Yeah. All right. Yeah. Yeah. So yeah. So actually, we pretty much we finish this slide quickly. Yeah.